I'm going to start again. I'd like to welcome everyone to this webinar on innovation, which is sponsored by Power Tool and construction fixing specialist Hilti. This webinar is part of Building's week-long series of events examining how digital technologies can revolutionize construction. I am Thomas Lane, the technical editor of Building Magazine. The need for construction to become more efficient has been thrown into sharp relief by the impact of the pandemic on productivity. Fortunately, there's never been a shortage of new ideas, tools and applications with the potential to transform the way we work for people working within the industry. Today, we're going to hear from 5 industry leaders who have developed innovative solutions that could help the industry deliver better buildings more cost effectively. So today's panel includes Razvan Gorcha, who is the International BIM Manager at the Hilti BIM Competence Center, who will talk about the benefits of BIM. Philip Watson, the Head of Design at Architect HLM, who will discuss their Thoughtful Toolkit, a suite of 3 design tools that helps designers deliver better outcomes for building users. Jamie Johnston, a director of Bryden Wood, who will talk about the Prison Housing app, which has the potential to deliver homes in London twice as quickly with less waste. Ben Robinson, a computational designer at Hawkins Brown, is going to talk about their Revit plugin, HBERT, which enables design teams to quickly assess the embodied carbon content of different building components. And finally, James Pickard, the founding director of Cartwright Pickard, is going to talk about 7D BIM, a tool that integrates whole life costing and whole life carbon into the digital design process. So that's our speakers. Each speaker will talk for about 8 minutes roughly, and once the presentation's over, you will have the opportunity to ask questions. But if you want, you can submit any questions during the presentations as well. So without further ado, I'd like to introduce Razvan Gorcha from Hilti, who's going to talk about BIM. Thank you very much.
Hello everyone. I'm Razvan Gorcha, International BIM Project Manager in Hilti BIM Competence Center in Rotterdam. I'll be opening the stage today. We have a nice panel of experts. Thank you all for joining. I guess you all wonder what has Hilti to do with BIM and digital building innovation. Let me guide you through so you can see how you get there. Hilti, 100% family-owned company. It's more than a brand, it's a legacy. It was founded in Liechtenstein by Martin and Eugen Hilti. Next. And now it has more than 25,000 employees worldwide, and we are driving building construction innovation in more than 120 countries. Next. We offer more than tools and more than supplies. We are providing complete solutions. We concentrate mainly on anchoring, fire stop, and installation systems, combining measuring and detection tools with software and engineering services. Next. Because with our direct sales approach, we are taught every day by our customers about their pain points and what they really need on the job site. We have this end user knowledge that is enabling us to comprehend what can we bring upfront in the construction industry. So with our research development, as well as our specific competence centers, we are constantly bringing new innovative solutions on site. Next. So we know that there are some key focus areas in the construction industry. And what do we do in the beginning? We establish a dialogue with the customer. So we're talking, and this is the role of BIM project managers and our BIM lead engineers in Hilti, to understand what is the specific field that is interested for our customer. And then we talk BIM. Please, next. we talk BIM, but not about a technology or a software, about BIM goals and use cases. We want to understand what is the reason behind a specific BIM project or our client. Next. That is why we are approaching the topic up front. Of course, you know this slide of the BIM effort. And we as Hilti, we are now encouraging the cross-trade cooperation, and we go in a partner mode, not only a problem solver like we traditionally do. Please, next. Because what we can see today, and you will see an image in the front, in the center of the slide, we see perfectly coordinated models, but they are incomplete. It looks clash-free, right? All those systems there. But what's happening is, although those models look clash-free, they are not done to be built on site. It's something missing over there. So please, next. And this, as you will see, is bringing loss of productivity, again, higher cost, again, risks, again, higher effort on the execution. Next. All the support system, they are not in a model. They are not coordinating. There will be clashes of coordination. There will be repetition. So here is where we come in. Next. So we identified 6 BIM use cases where Hilti can bring value to your project. There's design optimization, prefabrication, advanced logistics, BIM to field, validation, and back field to BIM. This brings value in cost, time savings at the overall scale of the project. It's also providing, my slide goes, added value as transparency, productivity, and also bringing back everything as an as-built model from the job site. Next, I will show you a video of the full solutions that we have for the construction industry with some specific projects where digitalization started tens of years ago. So you can see what we are able to provide in the pharmaceutical industry, laboratories, energy plants, etc., etc. We are covering a wide range of products, anchoring, and we are going to that kind of level that maybe you wouldn't think will arrive there. This kind of modular supports that you see in all these Anchorage solutions, and they are usually not designed, they are usually not modeled. And what Hilti does, we are designing it through our services with specialized engineers, and then this enables prefabrication. Everything is done off-site, and then it's delivered pre-assembled on-site. Our software is allowing us to have the right calculation, and with the total station and the robotic stations, we are implementing it on site. So that's why we are talking about a complete solution. Now, I have another video there for, let's say, more commercial side of the buildings. You'll see another range of products. And again, what we aim for is the multi-trade approach, where we can have here like a corridor of a hospital, for example, where we even think in 4D, where we consider the sequence of assembling different trades. So Hilti is collaborating in all the trades in the project as a partner. And you can see there the sequence of mounting, and we are delivering pieces by pieces on the right moment of the construction site. So this is enabling advanced logistics And together with this installation systems, next slide, please, we are also adding the fire stop solutions that we have. Also, a rather forgotten element in the construction, but bringing again a lot of pain and delays in the projects. Next slide, please. On this slide, what you can see is how we actually bring everything on site. It's the digital model. It doesn't stay digital. What you can see on the left side of the slide, you can see there are some markers, magenta color. Yeah, those markers actually are sent to a total station, which is a laser tool, a measurement tool that is actually bringing those points to be drilled on site. This is adding a lot of productivity, saving time, cost, and also assuring health and safety. The total number of people on site decreases significantly. And Hilti has another innovations coming. Please follow us next month. You will see some really nice tool that is also enabled by robotics and laser measurement. This is the complete end-to-end from digital to the job site solutions that we try to put together through our BIM services. Next slide. And you can see, for example, that we are talking about real projects that we are doing. I just took a screenshot of one of the projects we are supporting in the BIM Competence Center. We have around 40 big projects in Europe, and worldwide we have some hundreds of projects. This slide shows you only the Hilti elements that are modeled, and they are linked into the overall BIM project that we are working on. That was all on my side. Thank you. I think I'm in time, in the 8 minutes.
Great, thanks very much.
Curious to see the next presentations.
Great, thanks very much, Razvan. So over now to our next presenter, Philip Watson from HLM, who's going to talk about the Thoughtful Design Toolkit. Thank you.
Thanks, Tom. I'm not sure at the moment whether you can see my screen or not. Okay, are we good to go? Okay, right, good afternoon, everyone. Yeah, I'm going to talk about an innovation that we've recently introduced into our practice that we think is going to make a really positive impact on people, the people who use the places and the spaces that we're helping to create. And we call this the Thoughtful Design Toolkit. And I don't seem to have moved the slide. Yeah, I have. Okay. So the Thoughtful Design Toolkit contains 3 digital tools that help designers and commissioning clients to define, develop, and assess their building projects in an evidence-based way. There are 3 parts to the toolkit. The first is Insight, around defining the brief. The second, Health Check, around testing concept designs. And the third is Impact, which is a post-occupancy evaluation tool. Together, they address the universal challenges that clients and us as designers face in the creation of the built environment. So in terms of defining the brief, it improves stakeholder engagement, making it more democratic, helping to define a brief that can be expressed in an objective output specification where people's health and well-being is the primary focus. And then it tests these criteria and ambitions for design across the guide rails that we've created for designers. So we're testing the emerging concept design solutions. And then finally, it tests whether the brief and the design ambitions have been realized in the finished building product. And in turn, this creates a strong briefing process for the next project, a virtuous circle, if you like, of information and a database for best practice. So I'll go on now to describe each of these tools in a little more detail through the application on real projects. Now, the tools are still fairly new, and we do not have a single project that has yet gestated through the whole process. So I'm going to reference a project we call IC7 for the University of Kiel for the application of the Insight and Health Check tools, and then later a student residency project for St Andrews for the Impact tool. The University of Kiel were delighted to deploy our toolkit, in part because it helped them define the brief for a building that was new to them, a new department, and it also because it facilitated better engagement with their stakeholders. So the Insight tool presents itself as an online survey which engages with building users around the themes of well-being and activity. Accessible by any user group our clients wish to identify, it explores personal preferences for the quality of the built environment under a number of physiological and psychological criteria. The resultant data set, as you can see, is then used to help define the space standards and the environmental criteria of the brief. This process enables much wider engagement with building users than traditional methods would normally allow, and it's a more democratic and scientific method of capturing the brief. The insights that can be gained help shape our approach to design, enabling us to develop a building brief that genuinely supports people's health and well-being. For example, one of the key insights from Kiel was a desire to create transparency and accessibility within the building that might better facilitate collaboration and innovation. Another that was in this building for researchers who spent long periods of time on focused tasks was that they wanted views to the outside and biophilic design features such as planting and natural materials to help them feel calm and relaxed. And so armed with a data-driven brief, we could then develop an informed design response. So using our second tool, Health Check, we can quickly test emerging concept designs against the criteria of the brief to see how well they're performing. Health Check is a web-based tool that draws on database of climate weather files, CIBSE guidance, BREEAM criteria, and other best practice building guidance, which form benchmarks against which the emerging designs are assessed. So designers input criteria that describe the concept design in terms of site-specific aspects such as orientation, external noise, heights, adjacencies, window areas, and so on. And these inputs automatically generate a data model of the building that is tested against the benchmark criteria. The outputs indicate how the concept design is likely to perform against a range of environmental criteria, such as daylight, noise, heat, acoustics, and so on. A traffic light system indicates which aspects are performing well or not, with suggestions for aspects of the design to reconsider in order to improve their performance. And the key innovation here, for me at least, is that the tool relies on simple data inputs that are determinable by the designer at a very early stage. So there's no complex 3D modeling that might lead to abortive work. So in this way, the direction of the design concept can be shaped much earlier in the design process. And the final part of our toolkit is a web-based post-occupancy evaluation tool we call Impact, which we've deployed for the University of St Andrews, among others. This survey assesses whether the resultant building delivers the quality of environment and experience that was envisaged from the outset. The responses can be compared with the insight data at the briefing stage to see whether the building is, where it is, and where it's not performing against the brief. So this bespoke POE questionnaire draws on a number of industry standards to create a rounded, easy-to-use feedback platform that considers qualitative and quantitative aspects of completed projects. So another key innovation of this tool is that it enables a social return on investment calculation to be undertaken based on the data outputs. So this estimates the social value generated by investment in a monetarized way, which we think will become an industry standard for future public buildings in years to come. At St Andrews, this process has helped our client realise the importance of communal social spaces in halls of residence, and similarly, the importance of the provision of shared workspaces for students outside of their bedrooms, and a sense of connection with the natural environment to support health and well-being. These findings are being used to shape the brief for our next Hall of Residence project for the university. And so, to summarise the Thoughtful Design Toolkit then, each of the tools uses data to advance our understanding of what people want and need from the built environment. They enable designers to work in assurance that their proposals will deliver what building users demand, and they help clients make better informed decisions about targeting their investment in their facilities. Together, they form a powerful toolkit that benefits everyone. Okay, that's me. Thanks for listening. Happy to take questions as well.
Great, well, thanks very much, Philip. Just a quick question before we move on. Is this tool, I mean, is this exclusive to HLM, or are you going to market it as a tool that other architects could buy?
Honestly, I'm undecided about that. It's so new, and we've created it for ourselves. But already, actually, our clients are starting to ask us if we can do POE on other people's designs, and indeed we have been asked to help another architect shape the brief. So I guess the answer is always going to be yes, we will, but probably through our own consultancy rather than, licensing a piece of software, if you like.
Sure. Great. Well, thanks very much, Philip. So we're going to move on now to our next speaker, who is Jamie Johnston at Bridon Wood, who's going to talk about the Prism Housing Design app. So, Jamie, over to you.
Just firstly checking you can actually see my screen.
Not yet.
No.
Yes, that's great.
So firstly, apologies. There's been a mix-up because I'm actually not talking about Prism. I thought I was talking about platforms, so apologies for that, but hopefully still interesting. I think actually it ties in very neatly with what Razvan was talking about right at the front end. So for those who aren't familiar, the idea of platforms was to take 25 years of sort of various design for manufacturing assembly systems we've devised at Bridon Wood and turn it into, or crystallize it into a common kit of parts, perhaps. So maybe the closest parallel is IKEA. So as you know, when you go to IKEA, whether you're building a wardrobe or a chest of drawers or a bookshelf, a lot of the components are the same, the kind of knockdown fittings, but also the process is the same. You always get a manual in the same format. You only ever need a screwdriver and Allen key. So we're trying to identify, rather than focus on differences between sector types, look for commonalities. So for instance, healthcare wards and apartment buildings and education spaces all have about an 8-meter span, so you could start to commonize or get a common sort of kit of parts. This is the focus of the Construction Innovation Hub. So I was going to talk partly a little bit about platforms, but then what that looks like on a real project. So these are the sort of various flavors of platform that we've been developing as Bridon Wood, not as the hub. But you can see there's a range here from the sort of very small scale cellular accommodation spaces all the way up to sort of large span superstructures. I'm going to talk about one particular version of that, which is Platform 3 we're developing for Landsec at the moment. Across the platforms, again, like the IKEA book, some of the components the same, but actually a lot of the things we're repeating is the ways of working. So the digital workflows, the automatic generation of information, robotic welding, automation on site. So anytime we learn how to do one of those particular activities, we can instantly deploy it across all the platforms. So what we're seeing is a very rapid growth in terms of the maturity of these, and rather than have to learn it again and again on each sector, once we've nailed it once, we can instantly sort of deploy it cross sector. Once we have all of those, we can then start to, again, like manufacturing does very well, once you get a component you want to repeat multiple times, it justifies a huge amount of effort in optimizing each component. So if you're going to use a thing 1,000,000 times, every gram you take out of it, every assembly process has a massive multiplier. So we've started to think in terms of optimization of design. I won't go through all of these, but you'll see later when I talk about reduced build volume, that's rather than having separate zones for all mechanical electrical systems, you can compress them into a product. Material optimization, once we've got the superstructure components, we can then highly optimize those. Process automation, we're looking at how to sort of get fewer people on site, etc. So a lot of things that Razvan's talked about, that kind of end-to-end is exactly what we're kind of seeing with this initiative. So whilst we're developing these cross-government through the hub, Landsec, the developer, are the first people who are deploying this properly in the commercial space. So this is the building. It's called the Forge. It's about 139,000 square feet of commercial office just south of the River Thames. So you can see it's quite close to Tate Modern. So really nice site, very good proximity to the Thames. Obviously Landsec are well known in this space for doing lots of things around Victoria. So fantastic client for us because they've got a huge wealth of experience. They know exactly what the London office market's looking for, and we were given the opportunity to deploy some of the thinking we'd been developing at kind of government public sector scale, specifically for commercial use. So we've developed a kit of parts. Part of it is obviously the superstructure. So we describe the superstructure as being like a carrier frame for the rest of the building. So whilst it's not the biggest part of the cost plan, you can imagine if you nail the superstructure and you get it millimeter perfect and it goes up very quickly, it's easier to imagine the MEP being a kit of parts that clips into place, the facade system being a kit of parts that clips into place. So what we found again for the optimization is by working very hard on the superstructure, you get this sort of chain reaction of benefit in terms of fewer components, more optimized components, better controlled logistics, fewer vehicle movements. So across this building, it's actually Landsec's first net zero building. You can see the impact of all of this. It means we've got a lot less superstructure. And then because of the way we've organized the MEP, we've got a lot less basement, less foundation. So you're starting to get some real tangible benefits in terms of not just cost, but also massively important carbon savings. It also, tying back to Razvan's point, the fact that we have those digital components and we're using the same components means we can start to deploy automation in the design phase. So rather than create a model of a building, we create a data description of the building. One output is that bill of materials, so we can instantly start to get cost and budget, etc. But actually the BIM model is then a view of that data set. So the BIM model you can see here is created automatically by taking that data set, getting the digital platform components, populating the model. So whereas BIM used to be the kind of central source of the truth, what we see now is the data set is the single source of the truth, and the BIM is one version of that. But you can imagine the speed it takes or the time it takes to generate a BIM model is incredibly quick. So changes get incorporated very quickly, and then we automatically get all that kind of richness of data off the back of it. We've also then been, again, because we're repeating components, we can now look at automation or what level of automation is appropriate at the kind of manufacturing stage. So we're using those components to digitally drive, you can see a robotic welding of the brackets, for instance. We're investigating now how to use that same model to drive automatic welding of the components. So again, you're starting to very, very closely link the physical and the digital, and that's going to become a sort of increasing strand moving forward. We're also then on site using automation. So this was the prototype. We've got a prototyping center. This was to investigate what level of automation is appropriate on site. So again, like you build your IKEA wardrobe in your bedroom, how few people do we need? How few specific tasks, how much repetition can we get? So this was looking at how to build a slab from the slab below. So no one's ever working at height, no one ever needs to stand on that slab. And you can see with a handful of people, a little bit of automation that we've taken out of distribution centers, a little bit of pumping, robotic leveling. We can deploy the superstructure with half the number of people very, very quickly to a much, much higher quality. And actually, on Razvan's point, we've got all of the MEP fixings already cast into that slab. So as soon as you strike the shuttering, you can then clip the MEP in. Within the MEP, we've got two versions of it. So we've got the same kit of parts or repeatable kits of parts, which allows Landsec to decide quite late in the day which type of cooling strategy to deploy, for instance, and then we just pick the components to suit. Obviously, that then clips straight into the superstructure. Again, we've been testing this on the prototyping center, so the speed of installation is incredibly quick, productivity is incredibly high. We were doing it for productivity gains, but you can imagine actually it really helps with social distancing on site, for instance, to have very few people on site. And then into the facade, we've applied the same thinking to rationalize the facades. What we found actually is because we've then compressed the MEP into a very, very tight zone, it allows us to have more glazing, which meant less reliance on natural lighting, which meant lower electrical load. So again, we start to get these chain reactions of benefit where these things start to create additional benefits to get, better use of building volume, better use of carbon, better use of materials, etc., etc. So these are the statistics that we've currently got on this project. Bear in mind, this is Landsec's first project like this, but it's quicker, much less carbon, quicker, more net lettable area, and all those benefits we expect only to improve over time. And all of the learning from this instantly gets ported across via my role as design lead into the hub, and again back into that kind of ecosystem of components. So every time we do one of these projects, the benefit gets captured, the learning gets captured, puts back into the kit of parts, then gets propagated across sectors. So we think there's quite an interesting or very exciting opportunity for us to move a number of sectors forward very, very quickly, and to get that kind of continual improvement, which is common in manufacturing, but less so in construction. And I will leave it there. Thanks for listening.
Great. Well, thanks very much, Jamie. That's an amazing presentation. It's got a couple of questions on that, actually. So, I mean, some of those images you showed us of the composite flooring being put in robotically and the slab laying. I mean, how much of the building, what sort of percentage of the building is using standardized components that anyone can sort of buy off the shelf, so to speak, and what sort of percentage has been specifically developed to kind of work with the platform approach?
So they're all, I mean, one of our key things was that all of the bits that we use are completely standard. Though actually it's almost a sort of a reaction to this putting everything off site. So for instance, you can see we're pumping concrete, which everyone thinks is a bit counterintuitive because it's got a very low PMV, for instance. But actually, if you precast concrete, you need a big factory, big laydown space. You then pick a big heavy thing up, put it onto a truck, transport it miles, pick it up. So we said, well, actually, if I use reusable shuttering, pump the concrete, then I don't need the tower crane, I don't need the hook time. I can get a precast quality product, but I've stripped out all of the things that come prior to precast. So counterintuitively, we're actually not necessarily moving everything off site, but saying if I can turn my site into factory-like conditions, I suddenly get away from all of that. So most of the things there are completely standard processes, completely standard components. One of the things was to try and leverage the existing supply chain and capabilities and lower the barrier to entry by not having to have a special factory and make special things and do special tasks. We're trying to, like IKEA, anyone can make a wardrobe, anyone can build an office block, potentially.
I see, and I presume with that makes the whole, I have a question that actually relates to this, but the whole issue around intellectual property. So, I mean, if Landsec has spent, a substantial sum of money developing specific components, I can see them being a bit reluctant to share that with the rest of the industry. But presumably, if they're using standard components, you can then take the process across to other sectors quite easily.
Yes, so we have a deal with our clients that every client is benefiting from everything we did for Circle Health and GlaxoSmithKline and Heathrow Airport and things, but the next client benefits from what we're doing for you. And Landsec have kind of appreciated that they're actually benefiting from all the stuff we've done for other sectors. A lot of it actually from public sector work we've done for Ministry of Justice and Education and things. So there's a nice, we think, sort of two-way discussion where Landsec are benefiting from things that we've done for public sector, but a lot of that learning goes back into the public sector to fast track what the hub's doing, for everyone's benefit. So Landsec is sort of benefiting from that, everyone does, but also be very hard for us to work out exactly what we could protect, because it's not the use of square hollow sections, it's not the use of brackets or bolts or pumping concrete. All of these bits are kind of standard things. The totality of it is quite beneficial, but I couldn't actually put my finger. It's a bit like a mirage. The closer you get to it, they go, I can't actually tell you what I would protect or put a patent on, because it's all standard techniques, standard processes, just reorganized. Right,
brilliant. Okay, well, thanks very much for that. So we're now going to move on to our next speaker. It's Ben Robinson from Hawkins Brown. He's going to talk about HBERT, have I pronounced that right, which enables design teams to assess embodied carbon. So thanks very much, Ben.
Thank you. Hope you can see my screen. Oh, there we go. Yes. So I a perfectly timed cough, so I hope I can get through all of this without coughing too much. But yeah, so hi everyone, I'm Ben Robinson. I'm a digital designer at Hawkins Brown, and I've been leading the software development of HBERT, our emissions reduction toolkit. I don't think I need to validate the environmental reasons behind developing such a tool, but purely from an architectural standpoint, if the industry's got any chance of meeting many of the environmental goals we're trying to meet, that we have to do something now, otherwise we're never going to get there. And we have found that much of the environmental analysis that's currently being done is taking place at the end of a design stage, after many of the high carbon decisions have been made, so it leaves little room to make meaningful change. And so we wanted to develop a tool that was specifically targeted at the concept design stage. So in 2018, we released HBERT, which is a free and open source Revit add-in, and this measures the embodied carbon directly from your Revit models. And you can download this today from our website or contribute to the source code through GitHub. But we thought we could push this a lot further and add more functionality and get over a few of the limitations from the first version. So since then, we've been working on version 2, which is our Revit to Web Whole Life Carbon Toolkit. I think it's worth clarifying that HBERT version 1, although it contained metrics for all of the key whole life carbon stages as defined by RICS, it didn't cater for operational energy use in module D, so we did not consider it full whole life carbon tool. We've now incorporated this in version 2, and so it is a true cradle to grave toolkit. And it's this data from the materials and our collaboration with UCL that is the backbone of HBERT. So UCL and our sustainability team have worked to get quite complex information from the ICE carbon database and product EPDs, and basically boil down that information into a spreadsheet format, which then can be embedded into all our Revit materials and web library. So here's just a high-level flow chart of how HBERT works. So first, all our design teams are able to apply materials and our standard families directly in their Revit models. We're then capturing this material and volume data, as well as every element's RICS category. We're pushing all of this into a HBERT splash screen, where we can also feed in data from the rest of the design team and run really quick analysis directly in Revit. We're then able to push this to our database for then more detailed comparison and visualization in the web. I don't really have the time to go into the Revit side of HBERT in this 8 minutes, but just to say that we've put a lot of work into basically rebuilding our templates from the ground up, and we've built a number of apps that run and manage HBERT, and as well as the HBERT splash screen, so users can run and see analysis immediately in the Revit model. And hopefully you can all see a video now. But once users have done the splash screen analysis, they're able to quickly upload to the web. And then everyone has access to our main project library. So here you can access your project. All the analysis that you've uploaded is shown. On the left-hand side, you have all your core whole life carbon metrics, the bar chart, which shows on the left-hand side how far off the scheme is from being net zero. Every single element in the scheme is broken down into its RICS category with its benchmarking shown. And this benchmarking is also shown at the top. So a comparison of the target benchmarks for RICS category against each of the true categories for this upload. Another core new feature now is the ability to download these data sheets of any analysis. So this gives all the key information on the scheme on one page that you can really quickly embed into presentations or reviews. And you can continue to drill further into this analysis. So here I'm isolating the facade, and now you can really quickly see the different impacts different designs, materials makes, or how the project has developed as it's gone through the work stages. And again, this can be used for presentations with the data sheet. And as soon as a project is uploaded to HBERT, it's also included into our whole life carbon leaderboard, and we have 2020 and 2030 targets on, and you just immediately get a sense of just how much work is needed as an industry to get anywhere near the 2030 benchmarks. in addition to the project analysis, and the great part of this now is this component library where our sustainability team have been working really hard to develop these data sheets for a huge number of typical build-ups and components, and it breaks a typical build-up of a wall in this case, all its key metrics and its embodied carbon. And again, these can be downloaded and used for reviews. But I think the best feature of this bit is that, and this is early doors, so we haven't got a huge number of components up, but design teams are able to then run immediate comparisons and compare different facade options in this case and see what its whole life impact would be on the scheme. And then again, download these and put into presentation format. And I think for me, that's the best feature of HBER. There's been a whole lot of work gone into the new front end and back end, but the ability to have immediate visualizations of what is quite complex information available on any one of our Revit projects is great. And it's alongside that, we're now able to get our past projects we're starting to run them through HBER, and we're putting together an office leaderboard of the total carbon impact of all our designs. And I think not only does it allow us to learn from past projects, see what we've done well and right, but it also, I think, holds us to account and holds teams to account of the impacts, and hopefully we all learn and get towards meeting our goals. So thank you very much.
Great. Well, thanks very much for that, Ben. It's interesting to know. I mean, you've done run some calculations. We could see what sort of reductions in whole life carbon you're getting once you've kind of gone through the process and optimised the building to reduce the whole life carbon impact.
So it's really hard at the moment because it's such early doors. We've only run the new version of HBER on a couple of projects. So it's more now looking back at the moment with what we've run and seeing what we should have done. So this really went live as version 2 in the last 2 weeks. But I think for me, because I was not a part of the sustainability team before this, so I didn't have a true understanding of just the scale of the task at hand. And I think when you start looking at the component library especially, it is eye-opening. And I hope that it will be the same for our design teams.
Great, well, thanks very much, Ben. So now over to our last presenter, James Pickard, who is going to talk about 7D BIM. I think you need to unmute, James.
Sorry, am I unmuted now? I think.
No, you're
right.
Unmuted, and we can see your screens. Great.
Good. Okay. Excellent. Well, thank you for the opportunity to explain in just 8 minutes the key aspects of 28 months of government-supported research. This project basically has resulted in the creation of a new prototype software platform developed by Cartwright Pickard. Is there a bit of a lag on the slide? Hang on. There we go. Okay. So our research was financially backed by a group of blue chip industry partners. You can see on the screen there, without whom the project would not have taken place. And we found it really helpful that these partners represent a broad cross-section of the industry, from building insurance, construction, manufacturing, engineering, and property development. So why have we invested 2.5 years researching the integration of whole life cost and carbon with BIM? Well, obviously, I think we're all aware of the government targets. The latest government vision for the construction industry is described in Construction 2025, and it obviously includes the effective use of digital technology for the development of sustainable and low carbon buildings. Our research seeks to harness 7D BIM to address these government targets that are on the screen, and of course the climate emergency that we're all facing. So these government targets have been set to address the poor productivity of the UK construction industry, which you can see from this graph is approximately 50% lower than the manufacturing sector in terms of output per worker. So BIM will improve productivity, but also creates the need to rethink our current working methods and to implement more highly integrated design and delivery processes. The built environment, as we all know, contributes around 40% of global carbon emissions and is the largest single sector identified by the UN. Our industry could have a huge impact on the reduction of global carbon emissions. Now, we all know the average carbon footprint of a UK citizen is around 10 tonnes per year. And if you divide this, divide the total annual carbon emissions from the UK construction industry by the number of registered UK architects, just as an example, you come up with this figure of 1,365 tonnes. By anybody's standards, architects have a huge gift and enormous social responsibility to drive down the carbon footprint of their buildings in construction and in use. Even with your typical UK citizen making sacrifices such as cutting out meat, cycling everywhere and not using air travel, you can see they're probably still at best half their carbon footprint and possibly save about 5 tonnes of carbon a year. Compare that with an architect's ability to make reductions. So as an industry, we're all focused on capital cost efficiency and to a certain degree embodied carbon. What this slide shows is that in fact the capital cost of a building represents only 20% of the total cost of designing and owning a building over its first 30 years. So we should all be really focused on the post completion occupation of the building rather than just the costs of building it in the first place. So again, this slide is an HM Treasury graph which shows that our opportunity to reduce embodied carbon is far greater in the early stages of a project, and our research estimates that 80% of the potential for reducing whole life costs and carbon exists in the concept stage, which is the first 20% of the RIBA work stages. So I think that some of the previous speakers have said similar things. So our aim is to integrate whole life costs and carbon considerations from the earliest stages of concept design and throughout design development. Firstly, we've had to standardize the information delivery process and develop a protocol for better information management using BIM. Secondly, we automated repetitive tasks and processes for integrating whole life cost and carbon through the development of a prototype software application to prove our concept. So how have we defined 7D? The true potential of BIM is in the data attached or linked to the 3D model, and we've carried out one of the first major research projects in the world looking into the integration of BIM with whole life costs and whole life carbon. So our dream from the beginning has been to create a valuable decision support tool to help designers make better choices. So as you will know, the provision and use of a file-based CDE is an essential part of stage 2 BIM compliance, but whole life cost estimation requires more sophisticated data structures in the form of object-based information storage. We've developed a design decision support tool which allows us to make informed decisions at key milestones during the design development process and to close the feedback loop. At the core is a web app. This is where the actual calculations happen and project information is stored. We decided against a desktop app for better accessibility and quicker deployment across large project teams. There are links to existing whole life cost and whole life carbon databases, and currently we support 3 different sources, although in the long term we hope to build live data that is fed back through standardized processes. So plugins allow us to pull model information into the web app and also present the results back to the designer, supporting them during the decision-making process. So here is a user story which shows a concept massing model. We would like to see this as a statement of how early we think whole life cost and carbon should be considered by the design team by opening the 7D tool in the ribbon, we are given some basic instructions of what to do next. Obviously, this is a very quick snapshot of how the software works. The 7D tool allows us to specify desired unit mix for different types of tenure and different methods of calculation, either by unit or habitable rooms. With massing and unit mix now set, we're given an estimate of the count of residential units and auxiliary areas that would fit into this concept model. So we can now proceed to the actual cost and carbon estimation via a single click. So we're now looking at a model which the design team would typically develop to RBA stages 3 or 4, with building components represented by specific model elements. However, we don't always want to remodel elements to test alternatives. We can see that the cost for aluminium windows is calculated by the tool, as calculated by the tools, around £3.3 million, and the carbon impact of 868 tonnes, both over 50 years. The 7D tool can identify elements by the classification, map them with entries from the cost database and carbon database, and undertake estimations of whole life cost and carbon. For this example, we want to compare the current aluminium windows against timber windows only. With only one window selected, we can activate the compare function, and the tool will find all other elements with identical classification. On the right-hand side, we can see that the current type of element and the last calculated whole life cost. Beneath, we're given the selection of similar elements from the linked cost and carbon database. Without changing the elements of the actual model, we're given the what if feedback or overwrite option. In this example, we can now see that the 425 windows, if made from timber, would cost us £4.1 million and emit an equivalent of 393 tonnes of CO2. This shows that by spending £750,000 more over 50 years, it appears to save 450 tonnes of carbon. That equates to a reduction of 50% or 45% just on the windows alone, 45% of the carbon from the windows. This is a 3D model viewer for clients and building operators to help them engage with the process. It uses actual CDE hosted model if a CDE is being used, removing the need for separate uploads and ensuring that the entire project team is using the current model. Apologies if the animation is lagging a little bit because I'm sharing my screen. Also within the web app would be dashboards providing in-depth analytics, helping the user to understand the relationship between components and design options. The first example showed the impact of different window materials, the cost and carbon breakdown at the different stages in the service life of the product over 50 years. Here we can see the impact of the choice of soft flooring, for example, in a build-to-rent apartment building, and the choices of the flooring the different choices can have on the maintenance cost over a 50-year period. Obviously, soft flooring is the single largest maintenance cost by a long way and would justify closer consideration of this material. So to finish, this slide just sets out what we believe are the wider benefits of 7D BIM, and this is a golden opportunity for the construction industry to harness digital technology to raise the quality and cut carbon emissions across the built environment. Thank you very much.
Thanks very much, James. It's an amazingly ambitious project. I mean, as you said in the presentation, data is the driver really for tools such as this. I mean, you must need a huge amount of data about products, carbon, how much embodied carbon, also data in terms of how long a product would last, how much maintenance it would need over its life, what the carbon impact of that would be. I mean, this is a huge job. I mean, where do you get the data from? And do you have the data, or is it a long job that it's going to take years to build out all the information?
There are whole life cost and whole life carbon databases in existence, and we have access to 3 of them. One of our project partners, the insurance company BLP, gave us access to parts of its database, which was very helpful, and we also have access to 2 other databases. So you're absolutely right. The software will only be as good as the data that it has access to, but we have developed the software so that over time each user of the software will be able to start to benefit from the data that's built up by all the projects. So the data will be anonymized, and there'll be a central source of whole life cost and whole life carbon data that will benefit every user of the software over time, but that will take time to build up.
I see. And I mean, the second question is, I presume this is a work in progress. I mean, is this going to be something that's going to be commercially available at some point in the future? And if so, when would that be?
Yes, it definitely is. So we basically completed this 2.5-year KTP funded research project backed by the industry partners that I've shown. And we are hoping to launch probably another 2-year period, which will take the prototype software that we've developed and turn that into a marketable piece of software that will be commercially available. So the answer is, watch this space. In sort of 2.5 years, that's what we're hoping to do, and it will be available for designers across the world, architects, engineers, clients. It will be available to everyone working in our industry.
Great, well, thanks very much. So we're out of time actually, so we don't really have any time for any external questions, but I'd just like to thank all our speakers today for their really interesting presentations. There's some amazing examples of innovation out there. There's some really groundbreaking thought going on just to break the mold of a process, traditional construction processes that really haven't changed much in 100 years. So I hope everyone who's working on these projects all the best of luck. And I'd like to say that today is the first day in Building's Digital Building Week. So everyone out there who's listening, please come back. You've got 4 more days of webinars and all sorts of things going on. So hopefully we'll see you then. So thanks to our speakers again, and thanks for all our listeners today for listening.
Thank you.
Thanks all.